Dear learner, welcome you again in the MOOC session on the course Principle of Electrical Sciences. Myself, Dr. Sanjay Agrawal, Associate Professor in Electrical Engineering, School of Engineering and Technology, IGNOU. In this particular session, we are going to discuss about the DC circuit. In this particular session, we will discuss about the series circuit, parallel circuit, and combination of series and parallel circuit. And we will also discuss about the current division rule, voltage division rule, and then how we can apply the mesh analysis and nodal analysis. In the last, we will discuss about how to convert star connection into delta connection and then delta into star connection. So let us start from the series circuit. In the circuit, a number of resistors are connected end to end so that same current flows through them is called series circuit. If B1, B2 and B3 are the voltage drop across three resistors R1, R2 and R3 respectively, then total voltage V can be written as B equal to V1 plus V2 plus V3. So what is this voltage V1? Because same current is flowing through this particular circuit, that is current I. So what will be the voltage drop B1 across resistance R1? This B1 is nothing but it is equal to I into R1. And what will be the value of V2 across resistance R2? It is I into R2. Similarly, you can also calculate the voltage drop across resistance R3. It can be calculated as I into R3. So total voltage applied across this series circuit V can be written as V1 plus V2 plus V3 is equal to IR1 plus IR2 plus IR3. So here you can see this I is a common in all three terms. So suppose you consider total equivalent resistance across this circuit is R. So total voltage can be written as V equal to IR. So equation will be now IR equal to IR1 plus IR2 plus IR3. So this I is a common both the side, left hand side and right hand side. So this I can be cancelled out. So you can write R equal to R1 plus R2 plus R3. So in conclusion, you can say the total resistance in series circuit is equal to the sum of the individual resistances. The common application of the series circuit. The first application of the series circuit is it is used for the decoration purpose where the number of the low voltage lamps are connected in series. In this circuit, all lamps are controlled by a single switch and they cannot be controlled individually. In domestic, commercial and industrial wiring system, the main switch and fuse are connected in series to provide the necessary control and protection. Now we have to understand the parallel circuit. So in this circuit diagram, you can see one end of all the resistors is joined to a common point and other ends are also joined to another common point so that different current flows through them is called parallel circuit. So total current I can be written as I equal to I1 plus I2 plus I3. And what is the value of this I? Because whatever the voltage applied across this circuit is the common to the resistance R1, R2 and R3. So I can be written as B upon R1, I2 can be written as B upon R2 and I3 can be written as B upon R3. Let total resistance across this parallel circuit is R. So I can also be written as B upon R. So this final equation can be written as B upon R is equal to B upon R1 plus B upon R2 plus B upon R3. Just take the common V. So this B will be cancelled both the side at left hand side and right hand side. So final equation will be 1 upon R is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. So reciprocal of total resistance is equal to sum of the reciprocal of the individual resistances. It is to be noted that all the appliances are operated at the same voltage and therefore all of them are connected in parallel. Each one of them can be controlled individually with help of separate switch. Now we have to understand the series and parallel circuit. So here in the circuit you can see between the terminal A and B there are two resistance R1 and R2 are connected in the parallel. So equivalent resistance between terminal A and B can be written as 1 upon RAB equal to 1 upon R1 plus 1 upon R2. Similarly, between terminal B and C, there are three resistance, that is R3 and R4 are connected in parallel. So what will be the equivalent resistance between terminal B and C? It can be written as 1 upon RBC equal to 1 upon R3 plus 1 upon R4 plus 1 upon R5. So after the simplification, you can calculate the equivalent resistance between terminal B and C, that is R3 R4 plus R4 R5 plus R5 R3 upon R3 R4 R5. Now these two resistance, that is RAB and another resistance RBC, are connected in series. So if you calculate the equivalent resistance between terminal A and C, how will you calculate the equivalent resistance between A and C? That means you have to sum the equivalent resistance between terminal A and B and equivalent resistance between B and C. So total resistance R between A and C can be written as RAB plus RBC. Now we have to understand the current division rule. The current I has been divided into I1 and I2 into two parallel branches with the resistance R1 and R2, and V is the voltage drop across the resistance R1 and R2. Hence the current in each branch of a parallel circuit is inversely proportional to its resistance. The value of branch current can also be expressed in terms of total circuit current, that is I1 R1 is equal to I2 R2 is equal to I into R, where R is the equivalent resistance of this circuit. Because all these three are in parallel, so you can easily write I1 R1 equal to I2 R2 equal to IR, that is V. So what is this equivalent resistance R? Because these two resistances are connected in the parallel, so equivalent resistance R can be written as R1 R2 upon R1 plus R2. Now you have equation I1 R1 equal to IR. Now you have already calculated the equivalent resistance R, just put the value R in this equation. So you can write I1 R1 is equal to I multiplied by R1 R2 upon R1 plus R2. So what will be the value of I1? I1 is equal to what? I, that is total current, multiplied by the resistance R2 upon R1 plus R2. Similarly, you can calculate the current flowing through branch 2, that is having a resistance R2. So I2 can be written as total current I multiplied by R1 upon R1 plus R2. So the current division rule says that current in any of the parallel branch is equal to the ratio of opposite branch resistance to the total resistance multiplied by the total current. Now we have to understand the voltage division rule. Here you can see that in the between terminal A and B there is a one source, that is E, and between terminal A and B there is a resistance R1, between terminal B and C another resistance R2, and all these three elements are connected in the series. Now you have to find out the voltage across terminal AB and you have to find the voltage across terminal BC. So as per voltage division rule, we can easily calculate the voltage across VAB and voltage across terminal BC, that is VVC. The voltage division rule can be understood by the considering a series circuit shown in the figure. In series circuit, the voltage is divided whereas current remains the same. So E1 can be written as total voltage E multiplied by the resistance R1 upon resistance R1 plus R2. Similarly, you can calculate the voltage E2, that is voltage across terminal BC is equal to total voltage E multiplied by resistance R2 upon total resistance connected in series, that is R1 plus R2. So the voltage across a resistor in a series circuit is equal to the value of that resistor times the total impressed voltage across the series element divided by total resistance of series element. So the voltage across a resistor in a series circuit is equal to the value of that resistor times the total impressed voltage across series element divided by the total resistance of the series elements. Now we have to understand the nodal voltage analysis method. As I already told you, the Kirchhoff's voltage law, Kirchhoff's current law, so all these are the different tools to analyze the circuit. So third tool, that is nodal voltage analysis method. The nodal voltage analysis is a method to solve the electrical network. It is used where it is essential to compute all branch current. The nodal voltage analysis method determines the voltage and current by using nodes of the circuit. So here you can see there are different node has been shown in the figure A, B, C and D. Here you can see the potential of node C and node D is the same, that it can be taken as a reference node. So what are the steps to apply this nodal voltage analysis? First, considering the above circuit diagram, following steps are explained below. Step 1, identify various nodes in the given circuit and mark them in the given circuit. We have marked the node as A and B. So here you can see at node A, the different resistance are connected, resistance R1, R3 and R3. At node B, different branches are there which have resistance R3 and R5 and R4. Step 2 is select one of the node as a reference or zero potential node at which a maximum number of elements are connected, which can be taken as a reference node. In the given figure, node D is taken as a reference node. Now let the voltage at node A and B as V suffix A and V suffix B respectively. Next step is now apply the KCL at different nodes. So now you apply the KCL at node A. Here you can see the I1 and I2 and I3 all are the outgoing current. So as per the KCL, the algebraic sum of current at any particular node is equal to 0, or you can see incoming current is equal to outgoing current. So here you can apply the KCL at node A. You can write I1 plus I2 plus I3 is equal to 0. Now you have to find out what is the current I1. So because current I1 is flowing from terminal A to terminal D, that means it is assumed that potential of node A is higher with respect to the potential VD. So at terminal D, potential is what? V1. So what will be the value of current I1? I1 can be written as VA minus V1 upon R1. And what is the value of current I2? I2 is equal to VA upon R2. And what is the value of current I3? I3 is current flowing from terminal A to B. That means I3 can be written as VA minus VB upon R3. Now put all these three current in equation, you will get the final equation like VA in bracket 1 upon R1 plus 1 upon R2 plus 1 upon R3 minus V suffix B upon R3 is equal to V1 upon R1. This will be termed as equation number 1. Now applying the KCL at node B. So here you can see, just you have to apply the again KCL. Incoming current is equal to the outgoing current. So you can, after the applying the KCL, you can write minus I3 plus I4 minus I5 is equal to 0. So what is the value of current I3? I3 can be written as VA minus VB upon R3, and I4 is equal to V suffix B upon R4, and I5 is equal to V2 minus VB upon R5. So this is how you can apply the nodal method in any circuit. Now this nodal method can again be explained by taking some example. So here you can see there is a two node, that is node A and B, and here two voltage sources are there, that is one is 15 voltage source and another is a 30 voltage source. Now just you apply the KCL at node A. So this I1 is a incoming current, I2 is also incoming current, and I is a outgoing current. So after the applying the KCL at node A, you can write I1 plus I2 is equal to I. So what is the value of I? Because current is flowing towards the node A. So this value I1 is equal to, you can write 0 minus VA upon 4, because resistance across this branch is 4 ohm. So it is I1 is equal to 0 minus VA upon 4. And what is the value of this current I2? This I2 can be written as, because current is flowing from 15 voltage source to the node A. So this I2 is equal to 50 minus VA upon 5, and I is equal to what? Because current is flowing from node A to B. So this I can be written as VA minus VB upon 10. So after the solving this equation, we will get the final equation, that is 11 VA minus 2 V suffix V is equal to 60. Now because there is another node, you have to again apply the KCL at node B. So here you can see that I is an incoming current and I3 is also outgoing current, I4 is also outgoing current. So incoming current is equal to the outgoing current. So you can write I equal to I3 plus I4. So what is the value of this I? I is equal to VA minus VB upon 10. And what is the value of this I4? I4 can be written as B suffix B minus 30 upon 4. And what is the value of this I3? So I3 is current flowing due to the potential difference between VB minus reference node. That means it can be written as VB upon 6. So after the solving this equation, you will get the final equation 12 VA minus 62 VB equal to minus 900. So now you have a two equation and you have a two unknown variable, that is V and VB. So after the solving this equation, you can easily find out the value of the VA and VB. So after the solving, you will get VA is equal to 8.39 voltage and V suffix B is equal to 16.14 voltage. Now because you have to find the current flowing between node A and B, and what is that current? I, and I can be written as VA minus VB upon 10. So just put the value of VA and VB. So value of VA is equal to what? 8.39 and value of V suffix B is equal to 16.14. So after the solving, you will get the final current flowing between terminal A and B, that is 0.775 ampere. This negative sign is indicating that current is flowing in opposite direction. That means current is flowing from B to A in comparison to the A to B. So I is equal to 0.775 ampere and current is flowing from B to A. So this is how you can apply the nodal method in any particular circuit if you want to calculate the different branch current in any circuit. Now next method is Maxwell mesh current. This is also called loop analysis. In this method, mesh or loop currents are taken instead of branch current. The following steps are taken while solving the network by this method. First point is the whole network is divided into a number of meshes. Each mesh is assigned a current having continuous path. These mesh currents are preferably drawn in clockwise direction. The common branch carries the algebraic sum of the mesh current flowing through it. Second step is write the KVL equation for each mesh using the same signs as applied to the Kirchhoff's law. And third step is number of the equation must be equal to the number of unknown quantities. Solve these equations to determine the different mesh current. Now again we can understood the mesh analysis. Here you can see there is a three meshes are there. One mesh is A, B, F, E. Second mesh is B, C, G, F, B. And third mesh is C, D, H, G, C. So first you apply the mesh analysis in A, B, F, E. So you can write I1 R1 plus I1 minus I2 multiplied by R2 is equal to V1. So by rearranging the equation, we will get equation number 1, that is it can be written as I1 multiplied by R1 plus R2 plus I2 multiplied by R2 with negative sign plus I3 into R3 and value of this R3 equal to 0. So you can write I3 into 0 is equal to V1. So net equation is what? I1 multiplied by R1 R2 minus I2 R2 plus I3 into 0 is equal to V1. This is equation number 1. Now you apply the KVL in mesh B, C, G, F, B. So after the applying the KVL, you can write the equation I2 R3 plus I2 minus I3 multiplied by R4 plus I2 minus I1 multiplied by R2 is equal to 0. And after the rearranging, you can write this equation as minus I1 R2 plus I2 R2 plus R3 plus R4 minus I3 into R4 is equal to 0. Now you have to apply the KVL in C, D, H, G, C. So you can write the equation I3 into R5 plus B2 plus I3 minus I2 into R4 is equal to 0. After the rearranging, this equation can be written as minus I2 R4 plus I3 R4 plus R5 is equal to minus B2. This can be written as equation number 3. Now step 4. Now solve this equation 1, 2 and 3 to get the value of current I1, I2 and I3. By knowing the mesh current, we can determine the various voltage and current in the circuit. and this equation can also be written in the matrix form. So the above circuit can be solved by the matrix method also, as shown below. The above equation 1, 2, 3 in matrix form can be expressed as shown in this matrix, that is in the R1 plus R2, second is minus R2 0, minus R2, R2 plus R3 plus R4, minus R4 0, minus R4 R5. So this is a one matrix, and multiplied by the column matrix I1, I2, R3, and third one is a voltage matrix, that is V1 0 minus V2. So this equation can be solved by the Kramer rule also. Now equation 5 can also be written as matrix R multiplied by matrix I is equal to matrix voltage, where this matrix R is the mesh resistance, matrix I is the column vector of the mesh current, and matrix V is the column vector of the algebraic sum of all source voltages around the mesh. This is all about the mesh current analysis method. So by applying the Kramer rule, you can easily find out the value of the current I1, I2, I3. After the calculating the current different current flowing through any branch, you can simply calculate the branch voltage across any branch, that is current multiplied by the resistance. Now this mesh analysis can also be explained with help of some example. Here you can see in the example where there is a two meshes are there. First mesh is A, B, E, F, A, and second mesh is B, C, D, E, B. So just apply the mesh in A, B, E, F, A. So you can write the equation minus 2I1 minus 6, I1 minus I2 minus 6 plus 10 is equal to 0, because I1 is a loop current which is flowing in mesh 1 and I2 is a loop current that is flowing in mesh 2. So here you can see the current flowing through this 6 ohm resistance in middle one, that will be the net current, and that is I1 minus I2. So when you are considering mesh 1, just you assume that this I1 current is higher than I2 current. So net current is equal to what? I1 minus I2, which will flow through from B to A. And when you are considering mesh 2, that is B, C, D, E, B, then net current is equal to what? I2 minus I1. You assume that this I2 current is more than I2 current. So net current is I2 minus I1, which will flow from E to B. Now you apply the KBL in loop B, C, D, E, B. So after the applying the KBL, you can write that is a voltage drop across 3 ohm resistance. It can be written as minus 3 I2, because there is a drop across this voltage. It can be written as minus 2. In the again there is a voltage source 6, that it can be written as plus 6, because polarity is minus 2 plus. Again there will be a voltage drop across 6 ohm resistance, but due to the current I2 minus I2, it can be written as minus 6 I2 minus I1. So after the solving, that this equation can be written as minus 6 I1 plus 9 I2 is equal to 4. So now you have a two equation 1 and 2, and you have a two unknown variable. So after the solving this equation 1 and 2, you can easily find out the value of the current I1 and I2. So what is the value of current I1? That is 5 upon 3, that is 1.667 ampere. So you have a value of the current I1. Suppose you want to calculate the voltage drop across branch AB. So what will be the voltage drop across branch AB? That is I1 into R1. You have a value of I1, that is 1.667 ampere. Just multiply this current with to the 2 ohm resistance, then you can easily calculate the voltage drop across resistance 2 ohm resistance across branch AB. Similarly, you can calculate the voltage across 3 ohm resistance. You can easily calculate the voltage across 6 ohm resistance also. Now we have to understand the delta to star connection and star to delta connection. Sometimes the technique of series parallel reduction is not always applicable. In that situation, star to delta and delta to star reduction is very useful. So first of all, we are going to convert delta to star connection. Consider a delta and star connection as shown in the figure below. Here you can see in the delta connection there is a 3 resistance R1 which is connected between terminal A and B, R2 is connected between terminal B and C, R3 is connected between terminal A and C. And in a star connection, again there is a 3 terminal A, B and C. So if you want to calculate the resistance between terminal A and B. So what is the equivalent resistance between terminal A and B? That is RA plus RB. Similarly, resistance between terminal B and C is equal to what? RB plus RC. Resistance between terminal A and C in case of star connection, RA plus RC. So for delta and star network to be equivalent, it is necessary that resistance appearing between each of three pair of the terminal AB, BC and AC should be same. The resistance between point AB of delta connected network is what? RAB can be written as R1 in parallel with R2 plus R3. So it can be written as R1 multiplied by R2 plus R3 upon R1 plus R2 plus R3. So for star connection network, the resistance connected between terminal AB is equal to what? RAB can be written as RA plus RB. So for the two network to be identical, resistance between the terminal AB should be the same. So this can be written as RA plus RB is equal to what? R1 multiplied by R2 plus R3 upon R1 plus R2 plus R3. This can be written as equation number 1. Similarly, the resistance between terminal BC is equal to the two network can be written as RB plus RC is equal to what? R2 multiplied by R1 plus R3 upon R1 plus R2 plus R3. It can be written as equation number 2. Similarly, for terminal CA can also be written as RC plus RA is equal to R3 multiplied by R1 plus R2 upon R1 plus R2 plus R3. So by adding the equation 1, 2 and 3, we will get the following results. That can be written as RA plus RB plus RC is equal to R1 R2 plus R2 R3 plus R3 R1 upon R1 plus R2 plus R3. This can be written as equation number 4. So by subtracting equation number 1, 2 and 3 from equation 4, we get the following results. So RA is equal to what? R1 into R3 upon R1 plus R2 plus R3. This can be written as equation number 5. Similarly, RB can be written as R1 into R2 upon R1 plus R2 plus R3. And on the basis of this, RC can also be written as R3 into R2 upon R1 plus R2 plus R3. This can be termed as equation number 7. So the equivalent star resistance connected to a given terminal is equal to the product of two delta resistances connected to the same terminal divided by the sum of the delta connected resistance. Now we have to understand how to star connection is converted into delta connection. So here you can see in the diagram there are three resistance in the delta, that is R1, R2, R3. R1 is connected between A and B, R2 is connected between terminal B and C, and R3 is connected between terminal A and C. In case of star connection, RA and RC resistance are connected between terminal A and C, and between terminal A and B, RA and RB are connected, and between terminal C and B, there is two resistance RC and RB are connected in series. So for star to delta transformation, multiply equation number 5 and 6 and equation number 6 and 7 and equation number 7 and 5 and add all of them. Then you will get RA plus RB plus RB RC plus RC RA is equal to R1 R2 square R3 plus R1 R2 R3 square plus R1 square R2 R3 upon R1 plus R2 plus R3 whole square. So here you can take the common R1 R2 R3. So after the solving, this equation can be written as RA RB plus RB RC plus RC RA is equal to R1 R2 R3 multiplied by R1 plus R2 plus R3 upon R1 plus R2 plus R3 whole square. So this R1 plus R2 plus R3 will be cancelled by the R1 plus R2 plus R3. So it can be written as RA RB plus RB RC plus RC RA is equal to R1 R2 R3 upon R1 plus R2 plus R3. This can be termed as equation number 8. So divide equation number 8 by equation number 5 and equation number 6 and equation number 7 individually. So we will get R2 equal to RB plus R3 plus RB RC upon RA, and similarly you can calculate R3 equal to RA plus RC plus RA RC upon RB. Similarly you can also calculate R1 is equal to RA plus RB plus RA RB upon RC. So you can say resistance of an arm of delta is equal to sum of star resistances connected across that arm and product of the same two resistance divided by the third. So this is how you can convert star connection into delta connection and delta into star connection. Now this can also be explained with help of some example. So using delta to star transformation, determine the resistance between terminal A and B and the total power drawn from the supply in the circuit shown in the figure. So here you can see in the figure 1 there is a 3 resistance, that is 8 ohm, 3 ohm and 7 ohm. It is connected into delta. Now you have to convert this delta into star. So in the second figure you can see that is a branch of the star, that is R1 and R2 and R3. So by the conversion method you have to find out the value of this R1, R2 and R3. So R1 can be calculated as 8 into 3 upon 8 plus 3 plus 7, that is equal to 4 by 3 ohm. So after the solving the R1, similarly you can calculate the value of R2 resistance, that is 8 into 7 upon 8 plus 3 plus 7, it comes 28 upon 9 ohm. Similarly you can also calculate the resistance R3, that is 3 into 7 upon 8 plus 3 plus 7, that is equal to 7 upon 6 ohm. So resistance of RAB is equal to what? So in the diagram you can see so how these resistance are calculated. So by the equivalent you can easily calculate the resistance. So here you can see that 28 upon 9 and 10 ohm resistance are connected in series, and resistance 7 upon 6 and 4 ohm are connected in series, and these two equivalent resistance are connected in parallel. So after the solving this equation you can calculate the total resistance RAB, it comes equal to 5.039 ohm. Now because you have to calculate the power drawn from the supply, so power drawn from the supply can be calculated as V square upon RAB. So value of the voltage is what? 10. So 10 into 10, and equivalent resistance connected across AB. After the conversion from the star to delta and delta to star, you are able to calculate the resistance, that is RAB, that is 5.039. Just put all the value V and RAB in this equation. So power drawn from supply can be written as 19.843 watt. So dear learner, in this particular session we have discussed series circuit, parallel circuit, combination of series and parallel circuit, and current division rule, voltage division rule, and thus at the same time we have also discussed how to apply the nodal analysis and mesh analysis in any particular circuit, and for any complicated circuit how to convert star connection into delta connection and delta connection into star connection. So these all are the basic tools to analyze the circuit, and after the applying this nodal analysis, mesh analysis and star to delta and delta to star connection, you are able to find out the different parameter like current, voltage and value of the resistance. If there is a AC circuit, you can easily find out the value of the inductance and capacitance also. Thank you very much.